Hello to everyone watching this video. My name is Adam and I'm a back-end engineer on the Secure team. In this video, I'm going to give a brief demonstration of using dependency scanning to analyze a JavaScript project in an air-gapped environment, which is a feature added in release 12.9. Before starting, I'm going to assume that we have a working internet connection so that we can download all the required files to our local environment. A working internet connection is only required for the initial setup. Once all the necessary files have been downloaded and we've configured our CI environment, we can disable our internet connection and run a dependency scan in an offline environment. I'll also assume that the internal GitLab instance has been configured with an internally accessible Docker container registry. So we'll start off by creating a new project on our internal GitLab instance. In order to speed things up, we'll import an existing project by first clicking on the Import Project tab and then clicking on the Repo by URL button. We'll paste in the Git repository URL for a skeleton project which contains a minimal set of files required for demonstrating a dependency scan. We'll set the visibility of the project to public and then click on the Create Project button. Now that the project has been imported successfully, you'll notice that it consists of 4 files in a directory. The package.json and yarn.lock files provide a minimal set of files needed to run a JavaScript dependency scan. The JS repository.json and npm repository.json files contain the vulnerability data for the Retire.JS scanner. These files can also be hosted on an internal web server, but we'll include them directly in the repository to make the process easier. The node modules directory was added to simplify the configuration process. In a normal air-gapped environment, it would be necessary to set up a private npm registry, but we can just add the node modules directory to our repository to avoid doing this. Now that we have our skeleton JavaScript project, we can start downloading all of the required files needed for running in offline mode. We'll start by pulling the following Docker images. The first one is the dependency scanning Docker image for the GitLab registry. Next, we have the Retire.JS Docker image, also from the GitLab registry, followed by the Gymnasium Docker image, which is the last image from the GitLab registry. Now we need to pull the GitLab runner helper from the official Docker registry, then the Docker stable image, also from the official Docker registry, and finally we need the Docker in Docker image from the official Docker registry. Now we need to tag all of the above images to point to our internally accessible Docker container registry. The address of my internal Docker container registry is gitlab.adamc:5000. However, this will be different depending on your configuration. To make things easier, we'll use the same tags used by the remote images. The tag of the image is the part after the colon. For example, for the dependency scanning container, the name of the image is on the left side of the colon, and the tag is on the right side of the colon, and in this case the value is 2. You can see from this command that we'll tag each image with our internally accessible registry address and tag. For example, the dependency scanning image has been tagged with the address gitlab.adamc:5000/dependency scanning:2, where 2 is the tag of the image. Finally, we need to push all of the tagged images to our internally accessible Docker container registry. Now that we have all of the required Docker images hosted on our internal Docker registry, we can begin configuring our CI environment. In order to do that, we need to pay special attention to one of the Docker containers we downloaded, which was the GitLab runner helper. This is a custom GitLab specific container which handles Git, artifacts, and other operations and is required for our local GitLab instance to function properly. We need to edit our GitLab Docker runner configuration file to reference this helper. On my system, the runner configuration file is located in the following path. We need to insert a custom helper image directive which points to the GitLab runner helper that we previously tagged and pushed to our local Docker container registry. Once we've added this directive, we can save this file and the runner should automatically reload it. The next thing we need to do is to clone the GitLab Gymnasium DB Security Advisories repository and host it on an internally accessible URL. For this demo, I'll import this project into the local GitLab repository. First off, we'll create a new project. Then we'll click on the Import Project tab, then click on the Repo by URL button, and paste the GitLab Gymnasium DB repository URL into the Git repository URL field. We'll name this project Local Gymnasium DB, change the visibility level to public, and then click on the Create Project button. Now that we've downloaded all the necessary Docker images and support files, we're ready to edit the GitLab CI.yaml file for the project to reference the internally hosted files. We'll start by adding a new GitLab CI YAML file to the project. First, we'll include the dependency scanning template. Next, we'll override some of the variables and directives from the dependency scanning template to reference our internally hosted files and Docker containers. This custom image value will override the Docker image to point to our locally hosted image. Next, we need to override the services section to refer to the local copy of the Docker and Docker image. Notice that we've given this image an explicit alias value. This is necessary because the dependency scanning template expects that the Docker and Docker service will be accessible on the Docker hostname. Now that we've set up the custom image and service values, it's time to override some of the dependency scanning template variables. We need to set the SP version to the same tag that we use for our locally hosted Docker images. If you recall back to when we tagged our images, we used 2 as the tag value. So this SP version needs to be the same as this value we used here. Next, we'll override the Retire.JS advisory DB and Retire.JS node advisory DB variables to point to the locally accessible vulnerability files. These files were downloaded from the Retire.JS repository. If we browse the Retire.JS source and navigate to the repository directory, we can see where these files originally came from. Here's the JS repository file and the npm repository file, which corresponds to these 2 files. Next, we need to override the security scanner image prefix variable to point to our internally accessible Docker container registry. And finally, we need to configure the Gymnasium DB remote URL to point to the locally accessible URL for the Gymnasium DB. If you recall, we imported the Gymnasium DB project to our local GitLab instance, so now we can click on the clone button and copy the URL for the repository, which we can then paste here. Now that all of the required variables and configuration directives have been overridden, we can disable our internet connection to simulate an air-gapped environment. Now that we've disconnected our internet connection, we can commit the GitLab CI YAML file to the repository, which should trigger a dependency scanning job against the project. We'll switch to the pipelines view for the project and inspect the results of the dependency scanning job. If we scroll to the top of the job log, we can see that the Docker executor used the Docker images from our internally accessible Docker container. If we scroll further down, we'll see that the Retire.JS analyzer recognized that we've overridden the advisory DB and node advisory DB environment variables and uses the locally accessible versions of these files instead of fetching them from the internet. If we scroll to the bottom, we can see that the dependency scanning job has completed successfully. This now concludes the demo of running a dependency scanning job in an air-gapped environment. Thank you for watching.